Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Amazon Database Migration Service, or DMS, is AWS's fully managed tool for moving data into, out of, and across AWS with minimal disruption. Migrating databases has traditionally been one of the most challenging IT projects, often requiring lengthy downtime, careful coordination, and manual troubleshooting. DMS reduces this complexity by automating much of the process and supporting continuous replication to keep data synchronized during the migration. This means businesses can shift critical workloads to AWS while applications remain online, minimizing the risk of downtime or data loss. Whether moving from on-premises databases to the cloud, between AWS engines, or even across regions, DMS offers a structured, reliable path that prioritizes business continuity while easing technical transitions. At its core, DMS supports both homogeneous and heterogeneous migrations. Homogeneous migrations occur when the source and target share the same database engine, such as Oracle to Oracle or MySQL to MySQL. These are typically more straightforward, since schemas and query behavior are largely consistent. Heterogeneous migrations involve different engines, such as SQL Server to Aurora PostgreSQL, which requires not just data transfer but also schema and code conversion. These migrations are more complex, as differences in data types, functions, and stored procedures must be reconciled. By supporting both scenarios, DMS broadens its utility, making it suitable for organizations seeking either a lift and shift or a transformation to more cost-effective, cloud-optimized engines. The distinction highlights how DMS adapts to varied migration strategies depending on business needs. Central to how DMS operates is the replication instance, which is essentially the compute resource running the migration tasks. This instance manages the flow of data between the source and target databases, applying transformations, maintaining replication, and monitoring health. The size and class of the replication instance influence throughput and performance, with larger instances supporting higher volume migrations. For example, migrating a terabyte-scale transactional database may require a powerful replication instance to minimize lag, while smaller workloads can run on lighter configurations. Understanding this role is crucial. The replication instance isn't just infrastructure, it is the engine orchestrating the migration, balancing efficiency with cost depending on workload scale. Migration tasks in DMS revolve around source and target endpoints. These endpoints define the databases involved, including connection details, authentication, and specific configurations. By abstracting this setup, DMS allows migrations across many environments without redesigning the process each time. For example, a source endpoint could point to an on-premises SQL Server database, while the target endpoint points to an Amazon RDS PostgreSQL instance. Once configured, tasks can move data between the two with consistency. This endpoint model keeps migrations flexible, enabling reuse across different projects and making it easier to integrate heterogeneous environments. In effect, endpoints form the boundary conditions for the migration, defining both the start and finish lines. DMS supports three primary migration modes: full load, change data capture, and a combination of the two. Full load copies existing data from the source to the target in bulk, which is ideal for initial population of the database. Change data capture, or CDC, continuously replicates changes from the source, so the target stays synchronized during the migration. The combination mode runs a full load followed by CDC, ensuring that the target is fully populated and remains up to date until cutover. For example, an e-commerce system might copy all historical orders through full load and then use CDC to capture new transactions as customers place them. This approach minimizes downtime, allowing the application to continue functioning while migration progresses behind the scenes. Table mappings and transformation rules in DMS provide flexibility in shaping the migration. Table mappings determine which schemas, tables, or columns to include, while transformations can rename objects, filter rows, or adjust data formats. This allows organizations to migrate only what they need, streamlining processes and avoiding unnecessary clutter. For instance, a company might exclude obsolete tables from an old ERP system or transform column names to match new naming conventions. These capabilities make DMS more than a data copier. It becomes a tool for aligning old structures with new requirements. In large migrations, careful mapping and transformation planning can reduce both technical debt and future maintenance headaches. Validation and assessment reports are critical for building confidence in migrations. Before execution, DMS can assess source and target environments, highlighting compatibility issues such as unsupported data types or schema mismatches. During and after migration, validation tools check row counts, data consistency, and referential integrity, ensuring accuracy. These reports provide both technical assurance and business confidence, showing that the migration did not corrupt or lose critical data. For example, a financial services company might rely on validation reports to demonstrate to auditors that all records were transferred accurately. By embedding assessment and validation, DMS shifts migration from a leap of faith to a measured, auditable process. For heterogeneous migrations, AWS offers the Schema Conversion Tool, SCT, which works alongside DMS. SCT analyzes database schemas, stored procedures, and application code, then converts them into equivalent formats for the target engine. While not every feature translates perfectly, SCT automates much of the heavy lifting flagging areas that require manual attention. For example, an Oracle place/SQL stored procedure might be converted into a Postgres-compatible function, or at least marked for manual review. By handling schema conversion, SCT complements DMS's data migration, making heterogeneous projects more feasible. The pairing of DMS and SCT reflects AWS's holistic approach, moving both structure and data in tandem. Security underpins DMS, ensuring migrations do not compromise sensitive information. Encryption at rest uses AWS KMS to protect stored data, while encryption in transit secures communications between source, target, and replication instances. IAM roles govern who can manage tasks, and security groups define network access paths. For example, migrating a healthcare database into RDS might involve placing the replication instance in a private subnet, enforcing TLS for all connections, and tightly scoping IAM roles to approved administrators. This layered security ensures compliance with regulations while maintaining trust during the delicate migration process. By building these controls into DMS, AWS ensures migrations remain not only reliable but secure. Monitoring task health and throughput is central to managing ongoing migrations. DMS integrates with CloudWatch, offering metrics like latency, replication lag, and error counts. These insights allow administrators to detect issues early, such as falling behind on CDC during peak activity. Alerts can trigger when thresholds are crossed, prompting intervention before problems impact cutover plans. For example, if replication lag spikes during a sales event, administrators can scale the replication instance or adjust task settings to recover. By embedding monitoring into the process, DMS turns migrations into observable, manageable workflows rather than opaque background operations. Cutover planning is one of the most delicate phases of any migration. Even with CDC running smoothly, there comes a moment when applications must switch from the source to the target. Planning involves selecting a low-traffic window, ensuring the target is fully synchronized, and having rollback strategies if problems arise. For example, a retailer might cut over its point-of-sale system overnight, verifying transactions are flowing correctly before stores reopen in the morning. Rollback plans might involve keeping the source live until confidence in the target is established. This careful planning ensures continuity, reducing the risk of disruption during the transition. DMS supports a broad range of sources and targets, reinforcing its versatility. Sources can include on-premises engines such as Oracle, SQL Server, or MySQL, while targets often include Amazon RDS, Aurora, or DynamoDB. Even data warehouses and NoSQL engines are supported in certain configurations. This breadth means DMS can serve as a central tool for both lift and shift and modernization initiatives, unifying migration processes under one managed framework. For example, a company modernizing its legacy SQL Server application might use DMS to migrate into Aurora Postgres, simultaneously reducing licensing costs and embracing cloud-native benefits. By covering diverse endpoints, DMS fits into virtually any migration roadmap. Like most AWS services, costs for DMS are tied to resources consumed. The primary cost driver is replication instance hours, reflecting the compute allocated to migration tasks. Data transfer charges apply if data crosses regions or leaves AWS, while additional costs may arise from storage for logs or backups. For example, a small homogeneous migration within the same region may cost only modest instance fees, while a large heterogeneous migration across regions with extensive logging could incur substantial expenses. By understanding these components, organizations can estimate costs accurately and avoid surprises. Cost awareness ensures that migrations not only succeed technically, but also align with budgetary constraints. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Successful migrations with DMS follow a phased approach: assess, convert, migrate, and validate. Assessment begins with evaluating the source database for compatibility issues and identifying potential challenges, such as unsupported data types or stored procedures. Conversion is necessary in heterogeneous migrations, where the schema conversion tool helps transform schemas and logic to match the target engine. Migration then proceeds with DMS tasks, using full load and CDC to move and synchronize data. Finally, validation ensures data integrity and consistency before applications cut over. This phased model reduces risk by breaking down the complex process into manageable stages. For example, a company moving from Oracle to Aurora Postgres might begin with assessment reports, perform schema conversion with SCT, run a migration task with CDC, and finally validate row counts before cutover. One of the challenges during migrations is managing CDC lag, the delay between changes in the source and their appearance in the target. High volumes of writes, limited replication instance capacity, or network bottlenecks can cause lag to accumulate. DMS provides metrics to monitor this lag, and tuning replication tasks can help close the gap. For example, increasing the size of the replication instance or adjusting batch sizes can improve throughput. In practice, managing CDC lag is about ensuring the target stays closely synchronized so the eventual cutover window is as short as possible. Performance tuning thus becomes a balancing act, allocating enough resources to minimize lag without overspending. Pre-migration checks form a critical foundation for smooth execution. These checks include verifying primary keys, ensuring constraints are compatible, and validating that data types match between source and target. Missing keys can complicate replication, while mismatched types can lead to data truncation or errors. For example, a varchar field in SQL Server might not map neatly to Postgres, requiring adjustments before migration. Addressing these issues early prevents failures midstream. Pre-migration diligence is akin to inspecting an airplane before flight. Catching problems on the ground is far safer than discovering them mid-air. DMS encourages this proactive mindset by providing assessment tools and clear reporting. Networking plays a pivotal role in ensuring migrations are both fast and secure. Source and target databases may connect through VPN tunnels or AWS Direct Connect, depending on whether they are on-premises or in the cloud. Security groups enforce access controls, limiting which IPs and ports can interact with replication instances. For example, A healthcare provider might set up a dedicated Direct Connect link for speed and reliability, while using strict security groups to prevent unauthorized access. These networking choices directly impact throughput, latency, and security posture. Designing secure, efficient network paths is therefore as important as configuring the migration tasks themselves. Cross-region migrations introduce additional considerations, often used for disaster recovery seeding or global expansion. By replicating data across regions, organizations gain resilience against large-scale outages and can prepare for multi-region architectures. For example, a financial institution might replicate its transactional database from the US to Europe, ensuring continuity in case of a regional failure. While cross-region migrations incur data transfer costs and higher latency, they provide critical redundancy for regulated industries and globally distributed systems. DMS streamlines these efforts by automating replication paths, turning what would otherwise be a complex manual process into a manageable workflow. Testing is an indispensable part of migration planning. Pilot runs on small subsets of tables allow teams to validate configurations before committing to the entire dataset. Parallel runs, where both source and target databases operate simultaneously, provide a way to verify application behavior against both systems. Acceptance criteria, such as matching row counts or consistent query responses, confirm success before cutover. For example, an e-commerce company might run its catalog service against both databases for a trial period, ensuring data matches before switching fully to the target. Testing turns migration from a risky Big Bang event into an evidence-based transition, increasing confidence across technical and business teams. Automation further reduces migration risk by enforcing consistency. Pipelines and runbooks define repeatable processes, ensuring each step is executed reliably across different environments. For example, a migration pipeline might automatically assess schemas, launch DMS tasks, validate results, and generate reports. Runbooks document how to handle common issues, such as restarting tasks or resolving lag, giving teams a structured playbook. This automation prevents errors caused by manual intervention and accelerates timelines. It also transforms migration from an art into an engineered process, where outcomes are consistent and predictable. DMS's integration with AWS automation tools makes this approach practical at scale. Observability ensures migrations remain transparent and under control. DMS integrates with CloudWatch, providing metrics such as replication latency, task status, and error counts. Alarms can notify teams if thresholds are breached, such as replication lag exceeding acceptable limits. For example, during a critical migration, an alarm might notify administrators immediately if throughput drops, enabling rapid intervention. Observability shifts migration from a black box into an open system where progress is measurable and issues are visible. This transparency builds trust with stakeholders, demonstrating that migrations are not only progressing but also being monitored carefully. Data quality checks are a critical step after data has landed in the target system. These checks go beyond simple row counts to validate referential integrity, detect anomalies, and reconcile sums or totals. For example, a banking migration might reconcile transaction totals between source and target to confirm no funds were lost or duplicated. Reconciliation plans document how discrepancies are identified and resolved, ensuring accuracy. Without these checks, errors might remain hidden until users discover them post-cutover. By embedding reconciliation into the process, DMS helps ensure migrations deliver not only continuity but also correctness. Rollback and roll-forward strategies provide safety nets during cutover. Rollback involves reverting to the source system if critical issues arise, while roll-forward means continuing with the target despite minor issues, fixing them after cutover. For example, a retailer might decide to roll back if customer orders fail during cutover but roll forward if only non-critical reporting tables lag slightly. Planning these strategies in advance prevents hasty, ad hoc decisions under pressure. DMS supports both approaches by maintaining synchronization until the cutover decision is made, giving teams flexibility to respond as needed. Compliance is an ever-present concern, and migrations must often produce evidence for audits. DMS supports logging of task activities, including schema transformations, data transfers, and error handling. These logs provide an auditable trail demonstrating that sensitive data was handled securely and accurately. For instance, a healthcare provider migrating patient data could present logs showing encryption in transit and validation checks completed successfully. Compliance isn't just about passing audits, it's about proving trustworthiness to customers and regulators. By integrating compliance into migration workflows, DMS reduces the burden of demonstrating accountability. Sometimes native engine tools like Oracle Data Pump or SQL Server's SSIS may also be options for migrations. The key difference is that DMS is engine agnostic and minimizes downtime through CDC. If downtime is acceptable, native tools might suffice, especially for small, homogeneous migrations. However, when minimizing downtime is critical, such as for always-on production systems, DMS stands out as the superior choice. This flexibility makes DMS not just a technical tool, but a strategic enabler, supporting migrations where business continuity is paramount. For learners, this distinction is an important exam cue. From an exam perspective, the most important takeaway is that DMS is the managed service for database migrations where downtime must be minimized. If the scenario describes continuous replication, heterogeneous migrations, or cutovers with minimal disruption, DMS is the correct choice. Recognizing when to use DMS versus when a native engine tool might suffice is often the core decision. The exam emphasizes mapping use cases to services, and for migrations, DMS stands out as the service purpose-built for resilience, flexibility, and simplicity. In conclusion, Database Migration Service provides organizations with a managed, reliable way to move data while keeping systems online. Its support for both homogeneous and heterogeneous migrations, coupled with features like CDC, validation, and integration with SCT, makes it versatile. With strong observability, compliance support, and rollback options, it transforms migration from a high-risk project into a structured process. By minimizing downtime and aligning with modern cloud architectures, DMS empowers businesses to modernize confidently. For learners, the lesson is clear. When migrations matter and business continuity is essential, DMS is the AWS tool designed for the job. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.